Now we're going to talk about isosceles triangles. Now isosceles triangles have the property where two sides are the same length. We can indicate that on a diagram by putting little dashes in on the lines which are the same length. Another special property of an isosceles triangle is that the angles at the bottom of these lengths are also equal. So for example, if this angle down here was 65 degrees, then this angle down in the right corner is also 65 degrees. Using the knowledge that the angles in a triangle add up to 180, we can use this and say 65 plus 65 is 130, which means the top angle must be 50 degrees. If we change this and we get given an angle at the top of 70 degrees, then we can find out the angles at the bottom because we know that they're going to add up to 110 degrees. So if we divide those by 2, it gives us 55 and 55. Obviously all of these will still add up to 180. Sometimes in an exam we might get a question a bit like this, where we have a straight line attached to the bottom of an isosceles triangle where one of the angles is 110 degrees. We may then be asked to find the other angles in the triangle. First of all, we look at just this area here. We have a straight line where the angle adds up to 180. So 180, take away the 110, gives us 70 degrees. If that one's 70 degrees, then because it's an isosceles triangle, this one must be 70 degrees. And to work out the top one, we add those two together, 140, and take away from 180 again, which gives us 40 degrees. It's quite important to understand why these angles are, because in the exam question, it may ask you to explain your answer. Now, if you're talking about an isosceles triangle, make sure you mention that there's an isosceles triangle and that both angles at the bottom are the same. If you're talking about the question that involves the straight line, then mention that there's a straight line, the angles on a straight line add up to 180.